So how do you move from a traditional retail model to a modern, agile retail model? I am the Wizard of Pause.
This is a system I worked on way back in the 60s. And you can see the wiring is an enormous mess. Well, this is the same thing that happens when you build a monolithic model in the software world. You have interfaces that go all over the place that are all unique, tight coupling between things that require direct wiring, and you end up with a complex system that is so difficult to manage that it is virtually impossible to fix or upgrade. And then the problem becomes when you fix one thing, you break something else. Then along came the IBM backplane, in which everything just became plug and play. This was used in the PCs back in the early 80s, and all of a sudden it became easy to simply pull a circuit card out and plug another circuit card in there to do a different functions or simply to upgrade an existing one when you'd added some additional capability to it. So how did we get this way? What is the evolution of retail technology? So they started with one store, then eventually they added more and more stores, which led to the need for a common database so they could understand how the company was doing. So they created a silo for building this company-wide database. They then needed to be able to manage store inventories. And so they put a store inventory silo in place to handle that. And again, with multiple stores, you needed to optimize that by moving these into a warehouse model. And again, the warehouse was in its own silo. And the biggest mistake was the website, the online. In this case, they thought that the website was a flash in the pan. It was going to go away. So they created its own silo and thought that selling on the web was vastly different than selling in the store. So they created their own inventory for the website. And now they come into the problem with the modern buy online, pick up in the store world. To start with, one needs an underlying technical architecture. The modern version is a microservice version, where an application is broken into a set of services. These services are connected through a network where security and other things exist. These services then communicate with each other with a set of canonical messages. This is where the retail standards available at omg.org/retail exist, and they cover almost 90% of all messages you'll ever want to communicate between applications. The next piece of the puzzle is the choreography, and there are a couple of different ways to do that. All of this then exists in the cloud. That way it can be almost anywhere and dynamically scaled where needed. In addition to common messages, one needs a common retail data model to make sure everyone talks the same language. This helps to solve the common problem where one person calls something for sale an item and someone else calls it a product. In today's world, we have to incorporate information from devices. So the IoT world gets brought into the equation. And when you put all this together, you end up with something called unified commerce. It's a concept where anyone and everything connected to a customer shares information about that customer. And finally, to organize all of this is a business process model. I have another course that I'm going to be producing shortly, which will delve in deeper in each of these areas. You've seen this drawing before. It's a functional equivalent to that wired backplane, where everything is directly connected, everything has unique interfaces to it, and everything has vendor-specific interfaces to it, and you end up with a spaghetti bowl. So over the past 10 to 20 years, by implementing a myriad of applications to support their businesses, retailers have created this complex architecture. Linked together to share information is almost impossible to maintain and improve, and it implies tremendous numbers of inconsistencies. For example, you may have one application in here that calls something an item and something else calls it a product. They're the same thing, they just have different terms for them. Then along came the services architecture,
which basically said, let's break all of these things into independent services. Let's have clearly defined interfaces, the canonical message model, so that we can simply plug and play these things in here. And all of a sudden, we've moved to the IBM backplane. These services allow isolation of each business function and then enables individual replacement without impacting any other business. So how do all three of these relate? Well, you start with this big monolithic model. You then divided it into the service-oriented architecture, which was the model that was used in the late 2000s. It started dividing things. It unfortunately had a heavy footprint on using SOAP and the like to interface with it, and so it sort of grew out of favor. Then they took the next step and they divided these services themselves, the SOA services, into sets of microservices. Now, a microservice is an architecture is much more than simply a set of code. It's a whole deployment development methodology. So there's a lot more to it than what we will cover in this work. But we're going to cover it from an application point of view, not from a microservices point of view. One thing you can notice is that you started with one monolithic service, we ended up with 3 SOA services, and we ended up with 9 microservices. As the number of microservices grow, it becomes much more difficult to maintain and manage. Nothing is free. You never get anything free for anything. There are 2 major service components, so I'm going to reiterate them again. One is the service itself. That is the functions that are being performed by this service. The second part is the interface. And the interface is the standardized interface that should be derived from the ART standards. One thing you need to know is ART standards were created by over 1,000 subject matter experts. So there is a tremendous amount of retail knowledge embedded in those interfaces. The beauty of the container is it has all of the information that you need to be able to. So let's look at the microservices model. You start with the service and its interface definition. You put it inside of a container. If you need to, you can create something called a pod, which is multiple containers connected together for ease of finding them. So they need the kind of dependency between them in terms of the processes that they're being performed. You can collect them together in pods. You can put multiple pods out there. You connect them through a network. Again, you can have a container around your database, so you can do your CRUD access to your database through a standardized interface, and then the database itself can be located anywhere. You get the registry is the key component for finding whichever pod or whichever container has the services you need to perform with. You can again deal with native interfaces by providing a translator mechanism as a service put inside of a container that you interface with, so you can now start communicating in a standardized format across multiple systems following the same microservices model.
So now that you have a technical architecture in place, you have to have a process architecture in place. And that also has to be based on this Agile microservices world. And that is the heart of the Interactive Virtual Unified Retail model, or the IVRM model. There's another video that goes into the details about each of this. But what happens is it allows you to take your business strategy, focus it through value streams, identify the processes, the people, and the architecture necessary to execute that value stream, and the business intelligence necessary to monitor that and making sure you stay tightly focused to what the people at the top want. And then there's a new one bringing in human capital, so that human capital is an integral part of all of this.
This shows all of the standards that I helped create through the arts work, starting with a bunch of blueprints, basically requirements doc,
numerous design documents, technical reports, best practices, lots of interface standards. These are basically the lines on the previous screen. Device interfaces for communicating to printers, scanners, and the like. The data models, which is where ART started in 1993, and various requests for proposals to help retailers buy software.
So what is the microservice design approach? First, it focuses on building applications that balance speed and safety at scale, primarily through replaceability. This idea that driving towards replacement of components rather than maintaining existing components gets to the very heart of what makes the microservices special. So first, you break down it and decompose the application into business functional areas. You define microservices by these business functional areas. You use whatever appropriate ART standards or subset of those standards, because some of the ART standards are very large and don't apply to this particular service. So you carve out the component of the ART standard that you need for communication. For example, the pause log schema has somewhere around 6,000 attributes in it. Well, those are not all important for every service. If you had just a tendering service, for example, you might just need the tendering component or tendering area of the ART standard to do the communications with. And then you expose those services to be consumed by the applications. I don't need no stinking standards. Well, that's a problem. One of the flaws in the microservices world is they think that everything they're doing is unique and it hasn't been done before. But through my experience, the data that they use today is the same data that was used 20 years ago. That was the same data that was used back when they used cigar boxes for putting money in. Money is still counted the same. Items are still counted the same. Quantity is still counted the same. There's not anything really specific or unique to the modern world. So when people go out and start creating their own interface standards for microservices, they're going back to what happened to the 1990s. And now we're back to that model where we've got all of those wires connected all over the place because everybody thinks they know better than anybody else how to model that interface. Whereas they've got the existing ART standards that covers a vast majority of anything you can do in retail. And as noted, these standards were created by 1,000 subject matter experts. So you'll be very hard pressed for you to find anything unique that is in your system that doesn't already cover in the ART standards. And one of the beauties of these things is they're extensible. If you do have something that makes your application unique, and every application has some unique component to it, you can easily extend these things to bring in and add your new information without impacting interfacing with systems who have no clue what it is your extensions are. It's a beautiful approach. So, when to use a monolithic application, a SOA application, or a microservices architecture? Well, not all applications need to be service enabled. For example, if you have a time and attendance application, time clock doesn't need to be a microservice. It can be a traditional monolithic application because running a time clock is the same as it's been for years. So there's nothing special about it. However, the service for adding and removing employees to your time clock system could be a service because that is something that can be changed all the time when you start bringing in all the HR functions around it. So you have to kind of figure out which ones best fit what architecture. Stable static applications need not be migrated to a microservices architecture. Sometimes you can start with a monolithic design model and move to the microservices model when you're moving to implementations. In this case, what you might do is you might add microservices capabilities onto the outside of the monolithic application, and then over time, eventually migrate the entire monolithic application into a microservices world, rather than just trying to cut the whole thing out at once and create a whole host of microservices. It's an easy way to migrate from one to the other. Now, microservices don't solve everything. You have to understand a system as a whole. You have to understand what's dependent on what. And when one service instance fails, how do you figure out what the cause is? If you've got 100 containers out there running your code and one of them fails, which one failed? Why did it fail? What was it hooked up to at the time it failed? Lots of very challenging issues with figuring out the failure. When you make remote procedure calls, they're more expensive than in-process calls. Remote APIs need to be coarser-grained, which is often more awkward to use, and that's because you don't want a huge set of very fine-grained services running on your network and plugging up your network bandwidth and throughput.
Thank you. I am the Wizard of Pod. My name is Richard Halter. Please check out my book, Art for Retail, Using Technology to Turn Your Consumers into Customers and Make a Profit. It's available on Kindle. Thank you.